Okay, so I just poured the water up to the fill line, and so I will start my timer now. As you can see, it's already starting to go down a little bit from the fill line. And every 30 seconds, we'll pour some of this into there. Alrighty, it's been 30 seconds, and fill it back up to the fill line. And so the difference was, yeah, its difference was about 50 milliliters. It's been another 30 seconds, so pour a little bit more back in. Back up to the fill line. That difference was about 20 milliliters. Alright, it's been another 30, so we're gonna pour a little bit more in. Back up to the fill line, and that difference was about 25 milliliters. And alright, the timer just went off. Okay, I'm going to be answering the questions about the experiment. So for number 1, was the area of your can in square centimeters. The area of my can in square centimeters was 154 centimeters squared. How did my eye change with time? So this is my graph right here showing it, and it's a rough sketch, but it started off at half a minute. I had 0.16 as my rate, and then at 1 minute, the next 30-second interval was 0.081, and then at my last interval, 30 seconds later, it was 0.65. And so when I averaged those out for number 3, I got an average of 0.54 centimeters a minute, and then you convert that to millimeters an hour, and it was 324 millimeters an hour. What if there is a rainfall event and the rainfall usually reported as millimeters an hour is greater than I? What happens with the rainwater? Conversely, what happens if is lower? If the rainfall is greater, the soil cannot absorb it, so it just starts puddling up, and then inversely, if the rainfall is less than what I got for I, the rainfall will absorb at a faster rate. The soil will be able to pull it down and absorb it at a faster rate. What is the role of capillary action on water entering the soil? What will it have an effect on I? Capillary action helps the soil absorb the water and helps distribute it to nearby roots of plants. It helps it by the water can climb up or down using the capillary action, the molecular poles. And so capillary action helps in my experiment by absorbing the water I had poured in, and it distributes it to all the nearby roots of plants. Does the capillary effect remain consistent throughout an infiltration event? No, the role of capillary action depends on the amount of water that needs to be absorbed, so it depends on how much water is needing to be absorbed, so it doesn't remain the same. What is the effect of gravity on water entering the soil, and what effect will it have on I? Gravity helps pull the water down, which helps the soil absorb the water, and it helps my infiltration rate by helping the water get absorbed into the soil and pulling it down at a faster rate. What is the effect of vegetation on computing I? If soil has large pores and small pores, which pores would take a root from first? Why? So the vegetation helps the soil absorb the water because the roots of the vegetation will take in the water and use it for their needs. If the soil has both large and small pores, a plant root will take water from the large pores first because water is more readily available in larger pores due to gravity. And then for number 10, if you have the same soil on Mars, how will the Mars infiltration rate be different from yours? Explain your answer. If you had the same soil composition on Mars as on Earth, the infiltration rate on Mars would be significantly slower due to the planet's much lower gravity, and so it won't have gravity pulling it down and helping it absorb into the water. It'd absorb at a much slower rate.